The instructions that compare floating point numbers all work by comparing some value to the top of the stack, the ST0 register. This is the simplest form. It compares the value in the ST0 register with the source, which can be another register on the stack, or it can be a 32-bit or 64-bit floating point number in memory. This instruction does the same thing, but after the comparison, it pops the ST0 value off the stack and discards it. This form compares the top two values on the stack, ST0 and ST1, then pops the stack twice, getting rid of both values. This instruction compares the floating point number in ST0 to an integer. The integer can be a 32-bit or 64-bit number in memory. This instruction does the same thing, then pops the floating point number off the stack. And there is one special comparison instruction. This compares the contents of the register ST0 to the number 0. Now, these instructions don't set the bits in the regular flag register. They set bits in the status word of the coprocessor. But there are no branch instructions that use this status word, so the only way to branch according to the status word bits is to copy the status word into the flag register. And it's really easy to do. This is the status word instruction. It copies the status word into the AX register. Then it's simply a matter of using this instruction to store the AH register into the system flag register. Oh, and there's one more flag instruction. You can use this one if you ever need to load the flags into the AH register. This may seem to be a bit clumsy, but it's really pretty straightforward. This code snippet shows how it works. This FLD instruction copies a 32-bit floating point number from memory into register ST0. Of course, it converts it to the internal 80-bit format as it does it. The fcomp instruction compares the contents of ST0 to the 32-bit floating point value in memory. The bits in the status word have been set, so now the status word is copied into the AX register. Then the AH register is copied into the flag register, so the bits can be used for branching. To branch, you use the same instructions you would use after an unsigned integer compare. It never makes sense to check for one floating point number being equal to another, so the only instruction you will ever need here are the four above and below instructions: the jump above, jump not above, jump below, and jump not below. 4 more instructions. These are special cases that allow some common operations to be performed quickly. The FCHS instruction changes the sign of the number in ST0. The FABS instruction takes the absolute value of ST0. This is the square root instruction. It replaces the contents of ST0 with its square root. The fscale instruction multiplies ST0 times 2 raised to the power of ST1.